Good morning. All right, I'm going to go ahead and finish off the SL topic 8 information. We're going to start with 8.4, strong and weak acids and bases. Again, should be a little bit of a review from 2 years ago. Sophomore year, we went over this. So the pH depends on the concentration of the solution. The strength of acids or bases depends on the extent to which they dissociate in aqueous solution. The term ionization and dissociation can be used interchangeably, and the data booklet has a list of weak acids and bases. So this is information that comes from the directly from the guide, okay? So what it's saying is, obviously you know that the more concentrated a substance is, the more the pH is going to be higher or lower depending on if it's an acid or a base. In other words, the more H pluses there are, the more the lower pH, because low pH means more acidic, right? And more OH minus ions, and it's going to be more basic. So it's going to have a higher pH, closer to 14, higher than 7. You have, and what that depends on is whether that acid can dissociate or not a lot. If it can dissociate a lot, then it's going to be considered strong. If it can only dissociate a little bit, then it's considered a weak. The terms, again, it says ionization and dissociation are basically the same thing, basically dissociating, breaking apart into the ions, okay? So strong and weak acids differ by the extent of ionization, strong and weak acids and bases. So it's the same for both. If it's a strong acid or a base, then they're going to have higher conductivities than weak acids and bases. So if they are able to dissociate a lot, then they're going to be strong conductors. And if they are not able to dissociate a lot and they have only a little bit of ions, then they're going to be weak, in which case they're not going to be good conductors of electricity. A couple things to know. A strong acid is going to be a good proton donor, and it's going to have a weak conjugate base. And a strong base is going to be a good proton acceptor, and it's going to have a weak conjugate acid. So a couple things. You're going to have to be able to describe the difference between strong and weak acids and bases in terms of the rate of their reactions with metals, metal oxides, metal hydroxides, metal hydrogen carbonates, and metal carbonates, and their electrical conductivities for solutions of equal concentration. So remember those 5 equations we wrote down for those reactions. You just have to be familiar with those and describe them and explain what kind of products they produce. And based on the products they produce, you're able to discuss whether they are able to be strong or whether they are weak or strong, depending on their products. And then you could talk about their conductivities as well. So as we move forward, okay, that was basically all of 8.4. 8.4 just talked about you need to know the difference between a strong acid and base, or a weak acid and a weak base, and it all has to do with how well they're able to dissociate or break apart into ions in solution. Last section of the SL topic 8 is 8.5, acid deposition. So increased industrialization has led to greater production of nitrogen and sulfur oxides, leading to acid rain, which is damaging our environment. These problems can be reduced through collaboration with national and intergovernmental organizations. So rain is naturally acidic because of the dissolved CO2 in it. So, we're all breathing CO2. It's in the atmosphere. The rain collects in the clouds. When raindrops fall, they are naturally slightly acidic. Their pH is 5.6. But if it was to have a pH below 5.6, then it's now acidic rain. and it's called acid deposition. So acid deposition is formed when nitrogen or sulfur oxides dissolve in water to form any of these four acids. So you should know the names of these acids, but I'll go ahead and name them off anyways. The first one is nitric acid. The second one is nitrous acid. The third one is sulfuric acid, and the last one is sulfurous acid. So you are required to know these reactions here. Sources of the oxides of sulfur and nitrogen come from pollutants. These are the equations that describe the combustion of sulfur and nitrogen to their oxides. So this is how sulfur, these two reactions right here, this is how sulfur forms those two sulfur oxides. So the first one is just the element sulfur with oxygen, and it forms sulfur dioxide. And then sulfur dioxide reacts with more oxygen to form sulfur trioxide. And then these are the two equations that show how nitrogen reacts with oxygen to form its oxides, nitrogen oxides, okay? And then, so then on the bottom here, it says subsequent formation of those four acids. So once you have SO2, SO3, NO, and NO2, then in the next reactions, they form the four acids. And there's the reactions for those. So subsequent formation of those four acids is those oxides, sulfur dioxide, sulfur trioxide, nitrogen monoxide, and nitrogen dioxide. Each, when they react with water, they form these four acids. Okay, so if these four acids are in rain, then you see how it would the rain would be acidic. This chart I want you guys to study, and it basically just discusses how acid deposition, how acid rain, how pollution affects ecology, how it affects the earth, how it affects plant life, how it affects wildlife in waters like lakes and rivers. And so acid deposition consists of rain, snow, dust, or gas with a pH lower than 5.6. So make sure you guys study that. Now, I'm hoping that all of you guys have your blue book, and if your blue book is still at school, I don't know if they're going to allow you guys to get your blue books that you don't have on you, but there's some really useful information in there about the effects of acid deposition. So I've kind of summarized it here. The ecological effects of acid rain are most clearly seen in aquatic environments such as streams, lakes, and marshes, where it can be harmful to fish and other wildlife. As it flows through the soil, acidic water can leach aluminum from soil clay particles and then flow into streams and lakes. So the aluminum then is going to negatively affect the fish and other wildlife. And again, you need to know some ways to reduce. They are listed in the blue book. If you have it on you, then please look over it. Otherwise, I'll use my blue book. I still have to go back to the classroom to get a couple more things this week, and I'll add a list of ways to reduce here. All right, guys. That is all of topic 8. And so then the next thing is going to be to start topic 18. First, I want you guys to really study in 8.4 and 8.5 before we move on to topic 18. Okay?